Hello, good afternoon. My name is Jakub Nabrdalik, and let's start with this session. Now, I work as a consultant and as a solution architect with several companies, but basically I work from a perspective for the main customer, or basically the company I work for is called Bottega, where I travel across different companies that are trying to move to the public cloud. I also work with them in terms of actually developing everything and writing the code. So I spend about 15 days a month on actually coding with the team, and then about 6 other days per month on giving workshops or fixing the architecture, helping them design the architecture, helping them move to the cloud, or doing the consulting. And with all that, I kind of see the typical patterns and errors that companies make, especially small companies from 50 to 200 people in IT, small and medium sized, when they are moving to microservices, and they are quite common. So this is what I'm going to talk about today. So whenever I join a company and I want to help them when they are moving or when they have already moved, the first thing I ask for is an architecture diagram. And usually what I get is I get the picture when there is the standards, usual suspects, as you would say, the Kubernetes clusters, a big data lake, some old core system, which is already Dockerized, and then a bunch of applications all around it, and maybe some databases. But then I don't see on those diagrams the microservices, the logic, and I ask them, what is it that your developers actually develop? What's the logic? What's the services that you actually have, which are the core of the system? And they usually point me out to something like this in the middle of the diagram, or maybe in the bottom of the diagram, with no more details. And so the kind of a diagram that I get from people is the infrastructure diagram, and it's exactly the same diagram everyone else has. So if you think your company is very, very unusual, it's not true. We got all the same problems, and the infrastructure is very similar depending on the tooling you use, right? Okay, so when I dig deeper and I say, okay, now show me the diagram of the microservices that you actually have, they usually have none. And if they do, it looks something like this. And this is not a very helpful diagram. Now, this is just an example, but the real diagrams that I get are about the same. And if I'm lucky, I can get at least some kind of a responsibility chart for the teams that are handling those services. So as you can see here, there are several bounded contexts, like the basket ordering and so on. They talk through the event bus, but you have no idea what they're talking about. There are no messages described. There are no connections described. Basically, you cannot get any more information about how the system actually works. And that's the problem. Whenever I go to those teams that handle those different bounded contexts, they can describe their own context and give me a detailed architecture of their own teams. And then when I ask them how it fits with everyone else, they show me a different diagram, or they draw a different diagram. And those diagrams between teams are conflicting with each other. So basically, it's not possible that they are true, right? And this is a big problem, because one of the definitions of the architecture is that actually the architecture is the shared understanding of the people on the project. So at that point, I can clearly see that, well, there is no shared understanding between teams on the architecture of the whole system. So why is that, and how to fix that? Well, first of all, I got the good infrastructure diagram. And the reason for this is that usually when companies move from an on-premise to the cloud, these are the same people that used to handle the on-premise hardware and operations, right? So you usually have a team that is a small team, relatively small, that could be like one team for 200 developers, right? And that team used to handle the servers. Now they handle the cloud. And that's okay. That's a simple thing. There's just one team, so it's easy to coordinate. They get their job done, because if they didn't, you wouldn't even be on the cloud, and we wouldn't be talking, right? So that's cool. But then when I moved to the teams and the architecture of the microservices, there is a huge problem, And I've seen several approaches to that between companies. And the first one is that, well, if it used to be that there is the teams and the CEO, for example, did not have a partner, somebody who is good enough at architecture and would be recognized by the CEO or CTO as a good enough designer of the architecture, then the CTO moving to the public cloud actually asks for, okay, we need to hire another person, somebody who will help us design how the system should look like there and help us move, right? And the main problem here is they don't know who to hire. So actually, what they do is they ask an enterprise architect to do that, or they hire an enterprise architect. And the reason for that is that the enterprise architect has got a beautiful description of the job, right? It's somebody, and their enterprise architecture is a well-defined practice for coordinating enterprise analysis, design, planning, and implementation, and so on and so on. So it's basically whenever a CEO or CTO sees something like that, they say, I'm going to take it. That's what I need, right? Now, on the other hand, we developers know that if something is described like this, it actually fits any kind of a problem that you can have. So this is a general description of somebody that can help you, right? And there's a big chance that the enterprise architect that you're going to hire actually shouldn't design software because, well, enterprise architects are not really good at designing software. So we know that this description is a high-level bullshit. Okay, so what happens next is kind of scary because you ask that the CTO asks the enterprise architects to actually design the software and design the whole system, and we get something like this. We got boxes without arrows, and if you think about it, this is just a list. And it could be a tree-like structure. So basically, there's a list inside of a list because you got boxes inside of the boxes. But without arrows, this is not actually the architecture of the microservices. You don't know who is going to talk with whom and basically what they're going to say. What are the contracts there? Nothing, right? If even there are any arrows, then they are rare, like here, for example, when there's nothing that can give you any information, and these are just general and basically help you nothing to understand how the system works or how the system should be implemented as designed. So I thought that maybe I'm unlucky, and actually I just meet the bad enterprise architects that give me this kind of examples, and someday I'll meet a good one that will actually be able to design the software. And it turns out that's not the case because it's so popular that I actually jokes about it. And the reason for it is very simple. Enterprise architects are not people who design software systems, okay? They design the enterprise, which is the organization. So basically, when you ask them to design software, they don't know what to do and they know how to do it, right? These are the people that usually do not code anymore and are far away from the technology, okay? So when things like this happen, the best case scenario is that the developers ignore the diagrams of the enterprise architects, right? But in the worst case scenario, and that's quite popular, actually the devs start playing the blame game. So basically, everybody is bullshitting everyone, or just saying that it's your fault, basically, or they don't feel responsible because somebody is in charge and they tell them, and that person tells them what to do, and they know that that person does not have any idea about actually how the software works. So that doesn't work, okay? Now, the other case that I see quite often is when there is a single person, which is like a lead architect for the on-premise old system. And whenever there was a monolith, actually, that works. Because in a monolithic application, quite often you have maybe you will have 200 people working on it, but you have a single repository. And so when you have a single repository, you can check and verify the architecture. If somebody breaks the architecture, you basically go over to that person and talk with them. And that's the role of the lead architect usually. Like on the very beginning, it's the designing and actually the defining of the architecture. Then it's just fixing and making sure and sharing the knowledge, right? So that works kind of in a large organization when you have a monolithic application. But it breaks when you got microservices. And the reason for that is that even with 50 people and 10 teams, each team having, let's say, 4 Git repositories for microservices, you got 40 Git repositories, right? So what I see is that you have to make a lot of decisions, architectural decisions on the fly as you develop things, as you design things, right? And then the single lead architect wouldn't even be able to help you even if they wanted, and then they are not able to check and verify. So basically, that kind of diagrams that the kind of lead architect shows and draws makes no sense anymore because they do not represent the reality, right? And that's where there's another solution that several companies come up with, and this is the architecture guild, which is like, okay, so we know we got several teams, and each of these teams has to make architectural decisions. So, well, each of those teams need an architect, and it doesn't really matter whether you call them architects or whether it's just developers doing their job because the company is cheap and they don't want to give you a title so they don't have to pay you more. It doesn't really matter, but each team has got to make their own decision, right? And sometimes it works great, but this is not a talk about when it works great. This is a talk about when it works like this, okay? So basically a CEO and CTO, and I see quite often, calls for an architectural guild, and people say, okay, I'm going to join this architectural guild, whatever it is, and then they meet and they don't know what to do. So they don't create anything special. And what happens is that, well, after some time, it gets disbanded. So it's easy to actually kind of see how a dysfunctional guild works, because if they have only the private communication channel, they do not publish any outcomes, they have no practices, so basically no method of working together, they take no responsibility, and they do not publish anything. And this happens quite often. This is when people say, yeah, we have to work on this architecture, but actually we do not communicate with the outside world at all. And because the architecture is the shared understanding, the CTO or a CEO finds out that, well, it seems that it doesn't work because I don't know what they're doing. So maybe let's hire the enterprise architect again. So yeah, management needs a clear responsibility for, and they need to see the outcomes. But basically, all the developers need to understand what the architecture guild is about. So how to fix that? Well, there is actually a very good article about an architectural guild with 800 of people. Okay, but you can read it on your own. So I'm not going to talk about it. Instead, what I'm going to talk is I'm going to talk about my experience with building and working with an architectural guild for a year and a half now in a company that operates nuclear power plants. Okay, now just to be clear, I'm not working on the nuclear power plants. I'm working at the very end of this system, where actually I work on a system which charges your electric cars with the power from those power plants, right? But the company operates the power plants, and so it's not a very, like, let's say it's an agile company, but some things have to happen in order, right? Okay, so how can you make it work? How can you make the guild work? Well, the first thing you have to understand is that the guild needs to be responsible, which means that it has to decide about how it works, about the methods. And it has to write it down and possibly share it with others so that other people can understand. The CEO and CTO needs to understand what the guild is about, what they are responsible for. So basically, we started with actually preparing this kind of a documentation, and we just created a Git repository because, well, we are all developers, so why not use Git for that? It's perfect, right? And then we created Markdown document with README, and then they just wrote down and decided on, okay, what are we going to do? What are we responsible for? So first thing you have to understand is that every guild is responsible for sharing the knowledge, right? Because, well, the developers, each developer is an architect of sorts because they make changes and they make the decisions, and they have to make decisions on the fly. So they have to understand the bigger picture, right? So we start with actually sharing the knowledge and saying, okay, we need to draw the diagrams of the current system, of the system that we want to have on the public cloud, for example, and then show how we're going to transform from there to there, and basically allow all the people to make changes. Okay, so that whenever a developer makes a change, they can share that. It's not a job of an architect to verify those changes whenever they happen, or to keep the diagrams up to date. Actually, developers can do it whenever they change things, right? Okay, so the next thing is that we can work on common practices, because whenever you have several teams on microservices, well, you get a lot of things that are quite common. The same things that happen when you want to handle monitoring, right, for example, right? Or maybe SLA and defining the SLAs, and maybe the verifying it, or maybe stress testing, and maybe other things, right? So this kind of common practices, we will write them down, and when we see things that can be shared, then we will write it down and share it, right? The next thing is that quite often teams are so busy that they cannot do the kind of research that is required. For example, about, well, let's say we want to switch to the database as a service, right? And when a team is pushed from the product owner, they will use one of those without doing the proper research. So we can be that group, the guild, responsible for the technical research that nobody else wants to do, right? And because we can create recommendations, for example, which things and which software is actually good and works well and which doesn't and why. Then we can make the proactive changes to the architecture. And this is quite important because otherwise the architecture changes only when the development actually slowed down to a halt. And that happens quite a lot in the companies. Well, we can be better than that. We know what's going on from the business side, and we know what's going on the development side. So we can prepare the changes, the necessary changes in the architecture, and we can talk with the teams. Actually, we are the teams, so we can put that in our backlogs to actually change things before they break. And we can solve urgent issues, and it turns out there's a lot of them. So that's the first thing we decided to define, and we wrote that down and shared with everyone. Then we found out that, well, we need some kind of an interface to the rest of the world, to all the people. So we named a role called the Speaker of the Guild, and this is taken from the House of Commons and the British Parliament, basically. And the speaker of there, maybe you've seen the guys screaming like order all the time. And we decided that there will be a rotating role that you'll basically be on duty. And whenever you take this role and you take it for a sprint only, right? Then what you have to do is you have to ensure that whoever asks the guild, and we have a public channel for discussions, right, gets the answers in a timely manner, right? Now, the next thing you make sure of is that decisions are made, because whenever we see something which is like, okay, this is a kind of research we have to do, but it's not really interesting and it's tedious and we don't want to do it, there's actually not a single person that would like to do it, well, sometimes decisions are not being made and the research is not being made. And the speaker of the guild actually pushes everyone else in the guild to actually make things happen, right? Then, whenever we have an urgent issue, then we call for a working group. Well, we call for a working group so that, well, not the whole guild works on something, but let's say that we want to investigate a new way of logging and monitoring, for example, right? So we will create a working group, and people will just join that whenever they want, and we'll have 4 people perhaps working on that instead of having 20, because 20 is way too much, right? And that working group can create a proposal for how we're going to handle that, and we'll talk about it later. Then the speaker of the guild is actually calls for those working groups, and the speaker is actually accountable for process and outcomes. So basically, when the management and the CEO wants somebody, I need to be able to blame somebody for things not happening, you got that guy. Okay, and this is kind of a human interface of the guild. The nice human interface you can always call. There's the same email or the same channel, because we are using MS Teams, for example. So we have a channel there, and you can just call for help. You'll get the help from that person in terms of the architecture, right? Then we invite everyone to the guild, and we accept everyone, right? So we make no exceptions there. What happens is that at the very beginning, all the developers joined, or maybe not all the developers, but actually the developers interested in the high-level architecture and the low-level architecture, basically the most senior guys, right? Or the junior guys who were interested in that. But then later on, a lot of other people actually joined. The enterprise architects joined, because it turns out that they are very helpful and they can help you a lot, because they handle the whole enterprise, the whole organization. So basically, if you want to have like do a research about an off-shelf product, for example, this is a boring as hell for a developer. Enterprise architect can help you with that, and that person will be very happy to do so, right? If you want to maybe introduce some tool, right, the enterprise architect can do that as well, and so they are very helpful. So they join the guild. Not only developers are in the guild. And then we have to make sure that we are actually efficient and we deliver something, right? So we decided to actually have a sprints and work in sprints, as the whole company works in sprints. And we have a meeting every sprint to handle like the topics on the agenda and create the work groups and decide when we're going to have when we're going to provide what, right? So we go through the action points, we create all this kind of stuff. And if there is an urgent issue, we call for a guild meeting right away. And then we create those workshops. We publish a request for comments in Git repositories when we do a research. And then we ask everyone and we send an email actually about, we got a request for comments ready. Please read that, add your 5 cents. Maybe you will describe why it's stupid or why it's good, right? And then we will publish the decision or the actually recommendation, because we do not make decisions, we make recommendations as another file, which everyone can get to. So we have like a list of all the decisions in the history of the IT, right? Now, this kind of working with requests for comments is very common, and actually it works very well. There are several templates on the web where you can find out how to create the good request for comment. So whenever a working group actually researches something and different approaches to a problem, they publish the request for comment, and other people with completely different perspective can add the comments there. And basically we work in a Git repository on pull requests, right? So this is just a pull request, so everybody can comment that, everybody knows how to do it, everybody's easy with this, right? And then a discussion is ongoing, right? After a week of this discussion, usually the decision is being made about what to recommend, and then we move this template, the request for comment, to the actually architecture decision record. This is a kind of idea when you keep all the decisions together in a Git repository, so that you can return back to those decisions, and you still have the context, so you know exactly why you did it, what were the consequences, what are the alternatives, and why, what was the rationale behind making this decision, right? Later on, we found out that basically the RFC is exactly the same thing as an architecture decision record if you just mark which road you took, so basically which option you chose and why. So we just started to move them from one directory to another. So it turns out there's a lot of companies and organizations working this way, and it scales quite well. So if you have 50 people, it will work. But if you have 800, it might work as well, because, well, we got much bigger organization, and the whole internet basically is built like this, right? So the next thing I would suggest is to be transparent, because it's a normal thing when you know the people in the guild and when you're working with a group to like communicate with this group only, right? Because you know these people, you trust them. But that doesn't give people the chance to actually see what's going on and to take part in it and basically help you, right? So instead of doing private talks, we decided to have public communication channels. So we created a Microsoft Teams channel basically for the guild, so that we have the discussions there. We send an email whenever there is an RFC, and whenever a recommendation is being made, we also send an email, and so on. And we even create and send a newsletter every sprint. So basically every 2 weeks, we will send a newsletter about what we are working on, what we did, what kind of decisions we have to make, the invitation to RFCs, so basically everyone can join and add their 5 cents, and how you can contact the guild, because, well, there are new people all the time in the organization, and they need to know that this guild is accessible, right? So this is about transparency, and it helps a lot. Now, one of the things that people have problem understanding is that actually the guild does not make decisions. How is that possible? Well, we all know people who make decisions for us, and we have to live with the consequences of these decisions. And it's very simple and very easy to make a stupid decision when you do not have to live with the consequences. So instead of making decisions for others, what we do in the guild, we create this kind of recommendations. Like, we see that this is how it should be from our perspective. But if you as a team have a different perspective, and, well, it just popped up, so you had a chance to actually talk with everyone during the creation of the request for comments, but for some reason that wasn't obvious then. Now you know that this won't work. You can change that, and there's no problem with this. You have to live with the consequences, though, right? And at the very beginning, when we said, okay, so we are not going to make decisions, we just giving recommendations, people were like, well, in that case, everybody's going to drift in another direction. It turns out that doesn't happen. And we are talking about a guild which exists for a year and a half right now. And the reason for this is, first of all, well, there are representatives of all the teams inside the guild, okay? So you have like the kind of a peer pressure, like if we agree to kind of a decision to make something work, then what happens next is that you got somebody who said, yeah, that makes sense because I agreed to that, and he or she is inside the team that's making the decision. So basically, instead of like, okay, let's screw it, let's do something completely different, they usually come up to the rest of the guild saying, okay, we need to change that, and I don't think that recommendation is good anymore because of the given circumstances. Okay, so next problem is that actually not everyone is on the same level. And I love the book by Simon Brown, Software Architecture for Developers. It's a very boring book, but I love it because it actually brings everyone on the base level for the software architecture. And you would be surprised how many people who are working for tens of years in software development actually, well, when I was reading that book, it turned out that, yeah, I know most of it. That's why it's boring. But then I would turn a chapter and it was like, oh, I didn't think about that. And actually, I kind of like ignored that for most of my career, right? But this is something I have to think in the future. And this is actually something important for the architecture. And so we give everyone this book so that we bring them up to the correct level. And then in this book, and this is one of the important things about the architecture, you have to understand and be verbal about what do you actually focus on in the architecture, because there are the kind of quality attributes that you can aim for, but you cannot like get everything, right? So the basic thing is that what do you want to achieve? Do you want to have like security, right? And like everybody says, yeah, we want to be secure, sure. But is it more important, the security, is it more important than actually being able to maintain the software, right? Or how fast we develop new things? Or perhaps the performance is more important. And then you think like, okay, so the security is important, that's cool. But actually in what we do, and maybe the nuclear power plant is not the best example, but the charging of your car perhaps is, well, the security can be on the third place. And the first place would be actually we want to have high SLA so that it doesn't break, right? Or maybe, and for most of the companies, actually, all those requirements, the kind of a performance, well, you can run your services on a potato, to be honest. Like most companies do not have a lot of requirements in terms of performance or scalability or availability, but they all have the requirement of we want to not spend our time maintaining this thing. So we want to have a low cost of maintenance, right? So then you can optimize for this your architecture and decide on the tools and decide on the approach and the services so that you get that. Otherwise, what you get is I've seen teams spending 50% of their time actually maintaining old projects, and that's it. So this is quite important, and you have to also understand the constraints. But I recommend just reading the book, and you will see what happens then. Okay, so then we create an architecture diagram, and I love C4 diagrams, a C4 model actually for this, because what it is, it shows the things that developers understand. It's not UML. These are the containers and components, which are like modules. And for microservices, this is usually just a single diagram. And we created this kind of thing. And when we created this for the first time, and actually that was my second week for the customer, then I sent that diagram to all the people around, and I got an email from a product owner who said, "Thank you. I worked here for like 4 years, but this is the first time I see how the system actually works, and now I understand why some things are actually difficult to do because they touch a lot of different services, for example, or modules, and some things are easy to do and cheap, even though before that I wouldn't understand this, right?" So we created this kind of a diagrams. We sent it to everyone, including the CEO, CTO, right? And at the first, we were ignored. But then later on, my boss, so my people's manager, who manages me, actually, decided to actually hack the system. And he printed those diagrams on 3 meters by 3 meters kind of a sticker that you can stick on a wall. And it gave those diagrams to the CTO, right? So and out of a sudden, it appeared in every single office all across the Europe of my customer. And we had a picture when we could actually talk with the business and with the technical people about what's going on, right? And of course, this diagram gets out of date, so we have to print it again and put it on the wall again, but it helps a lot. And it turned out that people can actually use that to discuss. And before they had the diagram, they had like a fuzzy picture of, I don't know how the system actually looks, but maybe I understand how it works, right? A little bit. Then we teach the developers actually how to validate those diagrams, because, well, you can write the code and you can basically create the system and after you designed the architecture, but it's a lot of work. And it turns out, if it turns out that that makes no sense, that's way too late, right? Instead of that, you can create sequence diagrams, and you can use a website like web sequence diagrams, and you will automatically see, because if the kind of a system that you create makes sense or not, if you follow the sequence diagrams. Because this kind of a diagram is a static diagram. It shows you what you have and how it talks. These diagrams show you how it happens in time, and you will be able to verify. You don't need any special tools, but just following those diagrams, you'll be able to understand whether the processes make sense and whether your microservices, for example, are not too chatty. Okay. Now, having all of that, you still need to have this kind of a cross-cutting product teams, or you don't have to have them, but like the management actually ask for this. And when we say cross-cutting product teams, what we kind of think like cross-cutting team would be like a team where you have developers, the backend developers, front-end developers, so the team can handle itself, right? Now, it turned out that the managers actually think in other terms about it. They think about, okay, we want to have this kind of teams where each team can change any part of the system. So basically, they will go from project to project, from microservice to microservice, and they will make the changes that are required, so they can deliver a feature that the product owners want, right? And it turns out this is a very bad idea. And the reason why it's a very bad idea is described in the white paper, which analyzes why the Windows Vista failed so much, right? So basically, you know, if you've been using Microsoft systems, you know that every second Microsoft system is wrong, is bad, right? And the guys writing this white paper actually wanted to verify whether they can actually predict the number of bugs on a system based on the organizational structure of the company. And it turned out that they can. They created a model for that. And there are several outcomes of this paper. And these outcomes are kind of like things you would understand right away. Like I do agree with those, and you most likely will. But the CTO and the management actually do not know about it, right? So these are the failure metrics. If you have, the more engineers you have touching the code, the higher number of failure rate, right? So what happens is that, no, you don't want to have everyone touching every single possible repository. You want to have a team, and that team should actually work on that single repository, and that's pretty much it, right? So then the more edits to a component, the higher the instability, and that's the failure rate, which means that if you want to have a piece of software like a microservice, which is very stable, you don't want to have a lot of changes there, right? You can have a very shitty old software written without tests that still works well because nobody is touching it, right? And so on, so on. And coming from all these organizational failure metrics, which are quite easy to understand, it turns out that the way you have to set up teams is that each team has got to have its own code base, right? So basically, these are our microservices. I own them, right? I have to keep them on production, of course, because we are DevOps, so developers operate their systems on production. And we will do that. So we came up to the management and said, no, you know, your idea about how the teams should be split or how they should work is completely bullshit. And we have a better idea, and it's basically based on science. So you have the white paper there. And they said, well, that makes sense. That's okay, right? So they were optimizing when they wanted the cross-cutting teams, they wanted to optimize for the number of the discussions the product owners had. But what instead we should do, we should optimize to have as little communication between teams as possible, as little coordination as possible, right? In the perfect world, non-coordination whatsoever. And the product owners, well, those people do not usually code, but they are very good at communication. So how about they communicate as much as possible so that we develop things which create bigger features or bigger products for our customers, right? And when you have cross-cutting concerns, like the things like databases, monitoring, you have to manage the Kubernetes clusters, right? You can create another separate guild for that. And actually, this is what we did. Or you can create just a team. Okay, so these are the things that we found. And when we did that, the management actually said, okay, so you know what? If you're so good at it, why don't you design the whole teams and the structure of the organization instead of us doing this work? Because we think that you know what you're doing, right? And so we proposed something like that. Well, we assumed that the best way to communicate between teams is to have an event bus and basically to communicate only with events, using events with that. That's not always possible, and it's not always from the perspective of economy, it's not always wise. So basically, there are cheaper way to do it. But this ensures that you have some kind of a contract between teams, and this kind of contracts, and you can introduce consumer-driven contracts for the REST APIs and for Kafka, for example. Will not break, because these are the kind of a communication that are global, and you can read more about it on a book by Confluent, the Designing Event-Driven Architecture. So we created this, the management like that, and we got some good feedback from the management, right? But even though we got some good feedback, you kind of have another problem, which is that a guild is a bunch of people, right? And there are two types of cultures in Europe, and that's what Simon Brown writes in his book. But I completely agree with that, and I have both of them in Poland where I'm located. You have this kind of two different cultures of the management. One is empowerment and trust, and this works perfectly well with guilds, and the other one is command and control, and it comes from the UK, where they still have a queen, right? So this command and control kind of management doesn't work very well with teams, because they still want to control everything, and they have people like for example, a deployment manager, right? And it makes complete no sense because, well, if you got microservices, then of course you want each team to be able to deploy whenever they want, because that's the definition of the microservices, and that's the only way to go very, very fast. So you have to explain to them, and actually this is kind of a part of the architectural guild responsibility, to explain to them why it's not bad to actually have a lot of small releases now. Companies are afraid of doing big deployments because usually the big deployments are risky. So if you have monolithic application, if something breaks, everything breaks, right? With small applications, like microservices, that doesn't happen anymore. So we can explain it to them and show them how you're going to protect against when things break. And you can do it because you do A/B testing, automatic rollbacks on Kubernetes, for example, and you make your services resilient, right? But then there's another problem. And another problem is that QA have to change their mindset, because QAs usually want to, when they will come from the monolithic applications on-premise, they want to kind of do end-to-end testing. And this is not possible anymore when you have a distributed system. Because when you have a distributed systems and you have even 3 teams working on 3 microservices which have to communicate with each other, then the number of possible setups for the test environment is huge, right? And it grows exponentially, basically. So basically, you cannot be sure that whenever you deploy something to production, the other services are exactly in the versions that you tested for, right? So it makes no sense. Instead, we had to work with the QAs to actually explain to them that we are not going to do this. And instead, we're going to push on behavior and test-driven development, use consumer-driven contracts, and set up monitoring and production, and maybe even use chaos engineering to actually disrupt the production so we get like very resilient. Okay. And of course, the monitoring looks completely different. But the problem is that even though the teams were okay with monitoring the old system, with a distributed system and especially on public cloud, it's not that easy, because there's a lot of components there and there's a completely different knowledge there. And when teams say, okay, we got the monitoring handled, right? I'm on duty, I can handle this. Well, the question is, can you handle this at 3 a.m. when you are kind of drunk still after a Friday night evening, right, or whatever else, and can you handle that, or do you know how to do it, right? So the next step is actually to design this processes. So basically to write down how you're actually going to access all those things, how you're going to verify this, so that even if you're a little bit tired or maybe drunk, you can actually help and do it, right? Don't get drunk when you're on duty. Okay, the next problem that companies do make is they have the very old kind of mindset for the security. I've seen companies thinking in terms of the different layers of security. So basically, companies that say, okay, we are going to protect the production system, so we're not going to allow developers to use kubectl, for example, or kube control, right? And we will not allow them to see the production, and basically they are taking your tools from you, right? And when you have DevOps, developers operating the system on production, this is exactly what you don't want to do, because it will actually make it harder for you to debug, to understand what's going on, and to protect the system. You want to have all the possible tools. So instead of thinking in terms of layer, it's like, okay, you have access to the development environment, maybe to the test environment, no access to the production environment, or it's very, very limited, right? You can think in terms of actually doing something completely different, like creating a different cluster for each team, so that each team can actually have their own cluster and handle that. And this will protect them quite well, because even if one cluster gets penetrated, well, the only thing that the hacker can do is actually they can read the events from Kafka, maybe then they can send some events, but they have no access to the other parts of the system, right? So this is a different approach. And I've seen a lot of different stupid ideas about the security when companies were moving to the public cloud. I've seen companies which were taking over, and these are usually banks, taking away access to the internet for the developers, and all the developers actually hack that right away. So basically they set up a mobile connection, and basically because they need Stack Overflow and GitHub to do their stuff, right? I've seen companies which were only allowing for blessed dependencies, which were usually outdated and had security calls. So the developers would actually add artifacts on pen drive, because they wouldn't, the integration, and they would do the shadowing, basically unpack them, pack them again inside their code, so that you're not actually depending on external dependency, but just to hack around the security systems. And I've seen, and that was the worst case, a friend of mine actually worked in a company where they had to use JDK 6, and the only blessed language was actually Java, right? So the team decided that the kind of a problem that they work on is better solved with Scala. So they're going to do this. So what they came up with, and that was a bank, right? They packed all the Scala code inside the PNG files and basically image files, okay? And they wrote, in Java, they only wrote like a bootstrap application that would unpack those files, because those files were not verified by the security, okay? And run them and bootstrap them and run them, basically load the classes and start the whole Scala code after the Java code started, right? So I've seen so many hacks around the security that that companies have to understand that they cannot design the security so that it stops the developers from doing the job, because they are going to get hacked. And basically, if you run my code, okay, this computer is now mine, and it doesn't really matter whether it's actually then on premise or whether it's in the cloud. It's already mine. So stop bullshitting yourselves. We are not going to protect developers, or there's no point actually stopping developers from accessing the production system, because if it runs my code, it's already mine. Okay. So instead of actually doing this like in horizontal layers of security, we do it now by vertical slices, with each team having their own Kubernetes cluster. And it also helps a lot when we want to actually control billing, because we know exactly how much money each team burns, right? So there's a lot of benefits there, but it's very difficult to actually convince, and you have to teach the security of the large organization to understand that. And then you have to teach everyone the event-based architecture, or basically how to use the events and communicate in a manner where you're not saying what you want other people to do, but you are just saying your services are actually saying what happened in them. And this is a great book, and it's free of charge on the website. And it's even if you're not using Kafka, this is a very good book because it describes a lot of patterns there. And I would highly recommend to read that because it helps a lot when talking about the architecture later on. And then we have the open source and software as a service, right? So whenever companies move to the software as a service kind of approach, or the public cloud, they try to buy as much software as a service as possible because it's cheap, right? We don't have to maintain this. And the idea is that if you don't have to do the maintenance, it's gonna be very cheap and it's gonna be working okay because you got an SLA. Well, that's not exactly true. One day we found out that the CosmoDB cannot actually handle more than 50 inserts per second when we are using the MongoDB driver, which they completely support, right? And so I filed a ticket on the Microsoft platform about the problem on production. And I got the kind of a response, well, yeah, we see the problem. We can confirm that I see the errors, right? And I created and pushed on the GitHub repository, basically a public project, where you can run it and get the same errors all the time, right? And they said, okay, we are working on this. The next day, they said, we're still working on this. The next week, they said, we are still working on this. And we had that system on production. So for a week, we couldn't do what it was supposed to do. So we already decided, okay, let's drop CosmoDB. Let's use something completely different. We moved to PostgreSQL. A month later, they asked me if I still see these problems. So yeah, I ran the example that I gave them and said, yeah, sure, I still have that problems. 2 months later, they still didn't solve this, but asked me whether I still see this kind of a problem. So even though you bought software as a service, and you think that the SLA is like the very high, well, they couldn't solve the production problem for 2 months, right? Fortunately, we already forgot about this database. So this is an example. If you want to use a closed source solution, your hands are tied. You won't be able to do anything else there. So maybe instead of using a closed source solution, first of all, verify whether there's a lot of people using this. Are they happy with this? What they are saying about what are the feelings about? Call other companies, basically, right? And if it works for them, then do your testing, right? And if it doesn't seem like so good, maybe use an open source solution. Sometimes it's also provided by the public cloud provider, right? And that will always help you actually debug this problem and actually kind of find what the problem is. So to summarize, after a year, the architectural Git works quite well. And we got a lot of people actually involved, like about 50 or 60 people in the architecture guild, perhaps. And the management was so happy with us that they asked us to actually prepare the kind of IT strategy document, which is like a document designing where the whole company is going to go in terms of the IT. And in terms of not only the architecture, but the organization part, everything, tooling. And we did that, but we said to them, like, we're gonna keep this updated, right? We're gonna change this a lot. So whenever we change this, we're gonna actually let you know. But because we know that any big design up front is not good enough. There should be design up front, but basically things change, and we're gonna make those changes. And it turns out they are happy with this. Okay, so this is my rant about how to build an architecture guild, how it worked, and I'm over the times, I think. So let's see if I have any more questions to answer. There is one question there. What if all business microservices are inside the monorepository, not monolith? How to segregate teams then? Should we even do that? Well, my answer is don't do it. Like, have separate repositories. And the reason for that are twofold. First of all, you will have problem with the Git history. So Git history will not be as usable as it could be because, well, you see the history of all the other developers basically committing to their microservices. So there's no benefit of monorepository. And when the companies say that the Google has monorepository, Microsoft for the operating system, they have the monorepository, right? So they say, okay, we do that, and it's quite well. If you look in deeper, then they actually hack Git to get there, right? And they don't have real monorepository. They have hacked repository so that whenever you clone the repository of the whole Google, you're not getting all the data on your hard drive because it's impossible. There's like this laptop has got 256 gigabytes of RAM, of SSD, right? So you only get part of it. So I would say, don't do it. Another question: code has to pass review. Direct access to prod is different. Way easier to break stuff on your own. Is giving access to kubectl for junior devs a good idea? Well, I think so. Why? Because otherwise they do not understand. They do not feel. First of all, they are unable to operate this on production, right? So this is back to the situation when we had developers developing their stuff and they're pushing to somebody to deploy it, to make it work, right? Okay, so now you have pipelines. So you have automated deployment, right? What happens if a junior developer actually makes a push to the master repository, to the master, and basically it goes to the pipeline, but that something breaks, okay? And they have, okay, what's with the logs, right? Oh, we get no logs. What's going on with them? Well, you have to look at your nodes, and you have to look at your pods in the Kubernetes, right? So instead of thinking in terms of actually I'm going to protect them against doing that, how about helping your developers and junior developers especially get better at this? Okay, so if you don't feel like you don't feel comfortable going to production and changing things there, okay, breaking stuff, that means that first of all you could have designed this better so that a break in a microservice doesn't break the whole thing, doesn't break the whole system, and the features still flow, right? And second, you can work with that developer to make them better at actually handle these operations, because DevOps is developer operating the systems on production, right? Okay, next question. Do you integrate tests of consumer-driven contracts into host, provider, microservice, CI/CD pipeline? And the answer is that yes. But it's not that easy, because the tooling for the test and consumer-driven contracts, it works great for the REST APIs usually, right? It's not so great when you have to actually test the contracts on, for example, Kafka. But fortunately, you have you can have from Confluent, you can have the Kafka registry, I think it's called, where it's actually and move to Avro, for example, when it's actually these types of events have a schema instead of just going with JSON. But basically, yes, we do that. If we can, we always do this, right? Okay, I'm way over my budget. If you have any more questions, then let me know. I'll be here around for a moment. And one more thing is that you got two links here. One is for the presentation itself. You can always email me. And if you want to create your own architectural guild and you don't know where to start, this is kind of a boring repository with all the documents that we created, removing all the data of the client so that you can basically have a starter there. Thank you very much.